In this 8 series hardware overview, we are going to cover these topics: front panel, rear panel, electrical connections, magnetic modules, and front panel operation. So first, we'll look at the front panel. The front panel has this graphic control panels, shows the single line diagrams and the parameters, and also the soft key navigation menus and the keys below the menu. It has also several LED indicators, 14s plus 3 at the bottom for the programmable push buttons, and also have 6 navigation keys and a help button, and also a USB port, and the captive screws on the draw out handle. So on the top of the screen is the home screen icons, which show the status of these relays. You can see the first security. If it's green color, means it's secure. If it's a red color, it means unlocked. It also shows the active set point groups. By default, it's group 1, but this can be changed into group 2 to 6. And also it shows the Wi-Fi status, shows if any active target message, and shows the breaker status, healthy or unhealthy, and also if a file is saving, it shows that file saving status. And we can also see the circuit breaker status is open or closed, and we can see the load current and the measured VT frequency. So for the programmable LEDs, there are 14 LEDs on the top. 2 of them are not programmable, that's in service and pickup. So there are 12 programmable on the top and 3 programmable at the bottom. So totally 15 programmable LEDs. And this can be easily programmed either from the front panel or with the NVISTA software. And each one can be programmed into green, yellow, and red color, or green, orange, and red color. And for the push buttons, it can be used to send a command. Typically, by default, is push button 1 set as the trip, and push button 2 set to close, and the third button F1 is unprogrammed. So this can be used to send a open close command to the breaker, and once this button is pressed, the corresponding flex operand will be asserted. So now let's see the rear side of the relays. So on the rear side, we can see that the grounding screws, the power supplies, low voltage IOs, communication ports, high voltage IOs, and analog CT/VT inputs. So the first is the grounding and the power supply. So we can see now this is using only one ground for this 8 series, not like the SR relays need 2 grounds. And the power supply has the DC range is 125 to 250, and AC range is 100 to 240, 50 and 60 Hertz. And in the low voltage IO, which are used for the RTD and transducer inputs, one slot has 6 RTDs, and this measure range is -40 to 250 Celsius, and this RTD has this RTD voting in the configuration. That means it has to compare its pair RTDs to make sure that's a valid RTD over temperature. And for the communication slot, there are basic communication and advanced communication cards. So for the basic, it use only the ARIC B, RS485, and the copper Ethernet. And for the advanced communication Ethernet, it has the two fiber optic Ethernet connectors. For the high voltage I/O, which has the output relays and input contacts, which has, for the output relays, it has 2 form A and 3 form C output relays. The form A has a voltage monitoring, can be used to monitor the trip coil, closed coil, and the contact input can be set into dry and wet mode. And for the analog inputs or CT/VT inputs, we have a standard J slot for the feeder relays, or the optional K slot for the sensitive ground for the 850, and also for the 869 and 845. The second slot can be used as a differential relay inputs. Electrical connections. Electrical connections. So this is the typical 850 feeder relay wiring diagrams, and we can see the current used J card for the input. For the VTs, it has two types of wirings, the Y connections and open delta connections. For the open delta, we need just using 2 VTs. For the grounding inputs, it has these 3 types of connections. It can be used from the grounding CTs, or from this zero sequence CTs, or from the residual current from the 3-phase. And if the outer code has the sensitive ground enabled, that means you can have an input of in the J slot, so you can have a J slot to be used for the sensitive ground input. Again, there's 3 ways for the connections: the directly groundings, and from the zero sequence CTs, and the residual connections. For the 869 connections, this typical wiring has a differential really configured, and this is the internal summation method. So it's using 2 slots, J and K slot, and 1 connector for the terminal CTs, another connector for the neutral side CTs. And there's another way for the differential. It's just like the traditional SR relays for 469. It's a core balance differential wirings. So it's using core balance CTs to connect for 1 input of the K card. For the ground CT of 869, there's a directly connected to the ground from the zero sequence CTs, from the residual connections, or they can be used as a core balanced CT for the as a sensitive ground inputs. That will be used for the K slot, K7 and K8. For the 845 transformer relays, there are different type of configurations. Depends on the outer code. It can have 2 windings with VTs on the high and low side. So this is the diagrams of the VTs on the high side of the transformer. So it used the J slot cards J9 to J16 for the VT inputs, and J1 for the CTs of the high side, and K1 for the CTs of the low side. And then if you want to install the VT on the low side of the transformer, then the J slot will be connected to the low side of the VT. So J9 and J16 is connected to the low side of the transformer. There's another option in the order code is to choose 845 has only the CT inputs without VTs. So in that case, for J and K slot, CT inputs will be used and no VT will be used. And for the 3 windings transformers, in the slot J will be used for the CT1, high side CT, and the VTs, and for the slot K will be used for the winding 2 and winding 3 CT inputs. For the contact inputs, there are 2 ways to wiring the contact inputs. One is wet mode and another is dry mode. When wired in the wet mode, they'll be using external DC power supply to assert one contact input. So in that case, the terminal 20 will be used as a common. But if really want to be used in the dry mode, then the relay internal DC 24 volts can be used. So in that case, the terminal 21 will be used as a common. So there's 4 levels of the voltage threshold to use for the different voltage source of the substation. Because of the interference of substations, so we have to set the threshold close to the operating voltage level of the DC batteries. In that case, we can avoid some kind of noise induced in the DC system and causing the maloperation of this contact inputs triggering. For the contact outputs, for each card it has 5 relays, 2 form A and 3 form C, and the last one is a fail-safe relays, which means when the control power is removed, relay will be asserted. And for the form A contact, it has the voltage monitoring, can be used to monitor the trip coil healthy conditions. So here is the trip coil of circuit. First one has the no voltage monitoring. Then the second one has this monitoring with external jumpers. So here is the trip coil circuit without the monitoring. We can see that only when the 52A is closed, the trip coil will be energized. But we don't know that this trip circuit is healthy, any discontinuity in the circuitry. So if we see the second way to enable the monitoring, we can put external jumpers or even put bypass resistors. So see the first one with jumpers. So when the jumper is connected, the DC will go through the voltage monitoring, and when the 52A breaker is closed, so there will be a trickle current flowing through this circuit, so we can know that the circuit is healthy, it's ready to trip once the trip coil is energized by the trip contact. Then from the second diagram, when a bypass resistor is connected, that means even without 52A is closed. So that doesn't matter what's the status of the main circuit breaker. It can always measure trickle current flowing through the resistors, trip coil. So make sure that the trip circuit is healthy and can be used to trip the circuit breaker anytime when the fault happens. Magnetic modules. So let's take a look inside of the case of the 850 relays, so we can quickly identify each slot from the high voltage modules and the power supplies, low voltage modules for the RTDs, and the communication ports for the basic communication and advanced communication fiber optical connectors. And we see the bottom left, there's magnetic modules which has the CT, VT inputs. So for the J card and K cards. In the traditional SR relays and even UR relays, we're using the short circuit bars to protect the CT opening. And in the SR3 series and 8 series, we're using the magnetic modules. So once the relay is pulled out of this case, so the magnetic modules stays inside case. So that case there'll be no open circuit for the CTs. So that's a protection for the open circuit of the CTs. Now we're going to explore the front panel of 850 relays. From the front panel we can see the single line diagrams and the metered current of three-phase. And at the bottom we got the soft keys. We can check the firmware version by going to the status, info, and we can know that this is the 850 relays. Secondary CT is 1 amp, and this got outer code with 2E, means goose message 61850 is enabled. And we can also know this firmware version is 1.4, serial number of the product. Also check the COM information like the MAC address and also the hardware FPGA and CPLD numbers. From the metered screen we can see the summarized metered values of the three-phase current and voltage. Or we can see the single line diagrams, and this shown voltage is the average voltage of three-phase face-to-face voltage. And we can also see the phasors. So for the phasor, we can see the phasors of the three-phase current and voltage. We can also see the positive, negative, zero sequence current of voltage, and because I'm injecting a balanced three-phase, so we can see only the I1 and V1, that's the positive sequence. From the front panel of the 850 relays, we can check also the target message, which element has operated. We can also check the status of the breaker and the contact information. For example, the contact inputs, we see the contact input 1 is on. That's the configured as the 52A, the circuit breaker. And also we can check other information, for example, the output relays. In this case, we got relay 3 is operated. And under set points, we can set the basic system setup, for example, the CT primary. So we can enter, let's for example, 1, 2, 3, 4. So now if I go back and inject single phase current, so now I'm using this new ratios 1, 2, 3, 4 as my new CT ratios. Then we can check other informations as the VTs, frequency, harmonics. From the set point, we can also check other settings. For example, set the contact input voltage threshold. There's the 4 levels we can pick. And also we can set the protection element. Going to the protection and select group 1. And we can set the phase ILC pickup, and we can enable the frequency, enable this function by choosing trip alarm, latch alarm unconfigurable. And on the records, we can check the events, what element has operated. There's a event recorder. You can see the timestamps for each event recorder. And this also can be cleared by pressing the clear button. Press clear to confirm. So that's the basic operation with the front panel. Because there are lots of parameters in 8 series, so it's more efficient, it's better to use the software in Vista to configure more complex parameters. So this is just for a quick view and for very quick simple settings.